classic point and click. In the previous episode, we sealed some scripts. In this episode, we will enhance our animations with curves and add a destination marker to guide the character toward their goal. Let's kick off by fixing the placement of the player's peepers, for they be floating about a tad too much at the moment. I make sure to update the transform set with each keyframe. The current state is better, but to achieve even smoother animations, I can utilize keyframe assist and the animation curve. When needed, I can choose an automated preset by right-clicking on the required keyframes or manually adjust their curves using the Curve Animation Editor. That feels better. Let's examine our curves for any potential tweaks. That's all for the animation. Now let's focus on examining the destination marker in detail. Create a prefab with a reflective cursor immediately as a precaution. No need for the marker to play the game, mate. It's fully playable without it. Using the prefab unit feels like adding another feature to our game effortlessly. Just drag and drop, and it's good to go. We'll make a copy of our prefab and give it a new name. It's a breeze, trust me. To avoid messing up any working systems, I'll unpack the prefab. It's a safety measure to prevent accidental overrides. By unpacking the prefab, I can keep the game object's hierarchy intact while modifying its functioning script. There might be a more optimized way, but each element will get its own material for now. I can add more elements to the marker's hierarchy, like the ray hit animation. Using parenting and scaling, I can create a calm drip animation. Take your time, mate. Before recording the animation, it's important to fine-tune the mechanism. So go ahead and experience it at your own pace. Perfecto. Time to dive right in and animate our destination marker. First, we'll create the animator controllers and animations. Easy peasy. This time, we'll use legacy animation. We'll ditch the controller and opt for a simple animation object instead. To enable the legacy features, we need to turn on the debug mode. Just remember, once we're done, make sure to turn it off. It's crucial not to forget. Now, we can set the wrap mode for our legacy animation. When we drag and drop our animation, a special animation component is automatically created. It's a handy feature that simplifies the process. Creating a great animation takes time, Nate. If you need to, don't hesitate to take some breaks. It's important to give yourself a rest and come back refreshed. Start by animating each element in isolation. Once you're done, find the spots where the full animation can seamlessly interlace and play together harmoniously. We gotta attach this animation to play whenever we click on any interactable spot. It's all about making it interactive and engaging for the players. So let's get to it and make sure that when we click on those spots, our animation comes alive. No problemo. Nate, let's create a script for the destination marker. It will handle all the actions and behaviors related to the marker. Time to fire up the code editor and get cracking on that script. Let's do this game development style. We'll attach a transform and utilize the base awake method, just like before. However, this time we'll override the update method to customize the behavior. If the method you want to override is undefined, it means you're working with the marker abstract class. To override it in your destination marker subclass, you'll first need to define the method in the abstract class. Once that's done, you can customize it in your subclass. Remember, it's all about working within the boundaries of your class hierarchy. We'll start by checking if a click has occurred using your input status. If it has, we'll then retrieve the click position. It's all about detecting the user's click and getting the position where it happened. Before we draw anything on the game screen, we'll ensure that our marker hit collides with the ground object. To prevent unnecessary duplicates, we'll validate if there's already a destination marker in our scene before creating a new one. If one is already present, we'll just update its position instead. If there's no destination marker in the scene, we'll simply create a new marker game object. We'll set its position and parent it correctly. Next up, we'll create a game object to serve as a container for your markers. It's like a designated space where all your markers can stay together. This game object will serve as both a container for your markers and a spawner that creates new destination markers. Since you've made changes to the abstract marker class, it's essential to fix any related issues that may have cropped up. This is also a great time to do some light refactoring to optimize the script further. I couldn't create any markers because I didn't set the transform for my abstract marker. Let's test the marker behavior. When you click, it will show the animation. Just remember that the animation will play only once, according to the settings we've specified for the legacy animation. I've noticed a small glitch in my animation, so I've decided to return and fix it. The cause of the problem lies in the fact that the game object is never destroyed, and the animation can only play once. But fear not, we have a simple solution to fix it. We'll implement a self-destruction event that can be used in various cases. This way, we can ensure that the game object is properly removed when needed, preventing any unwanted behavior. Once we've created our self-destruction method, we can set it as an animation event. This means that we'll specify a point in the animation timeline where we want the self-destruction to occur. I can't seem to see the critical asset, and I suspect there might be something wrong with my code. We need to make sure we're destroying the correct game object, which is the parent object. By double-checking our code, we can ensure that we're targeting the right object for destruction. Great job so far, mate. The marker is working almost as expected. However, we've run into a problem when trying to reuse it. The issue is that the marker doesn't rewind its own animation and instead teleports to a new location with the current frame still playing. It's important to address this issue to ensure smooth and seamless marker functionality. Let's dive into the code and find a solution to make the marker rewind its animation properly when reused. To fix the issue, we'll grab the animation component of our marker. If the marker already exists in the scene, we'll use animation methods to rewind it, play it, sample its new position, stop it at the desired position, and then replay it. By utilizing these animation functionalities, we can ensure that the marker properly rewinds and plays when it's reused. To fix the visual glitch where you see the top border of your marker, you can make adjustments directly within your animation. Take a closer look at the frames and ensure that the top border is properly hidden or aligned. Take your time, mate, and fine-tune your scene to perfection. Everything is working smoothly, mate. That's it for this episode. In the next and final episode, we'll refactor all the scripts to improve our project even further. This project was created as part of my Unity Learn journey for educational purposes. Once it's complete, you'll have a ready-to-go classic point and click behavior that you can build upon and customize as needed. It's my way of contributing to the game development and Unity community. If you'd like to support my project and ensure the creation of more great game development content in the future, feel free to make a donation. Your support is highly appreciated. Keep up the fantastic work, my friend.